Hi, so in this video we will solve this integral from 0 to 10. This is the greatest integer function, square root of 10x over x plus 1. So what is the meaning of this greatest integer function? So this tells the greatest integer less than or equal to x. So if it is written like 3.14, that means the greatest integer which is less than or equal to 3.14 is 3. If something is written like 4.16, then the greatest integer less than or equal to 4.16 is 4. If it is like 0.5671, then the greatest integer which is less than or equal to 0.5671 is 0. And if it is like 4, then the greatest integer which is less than or equal to 4 is 4 only. So this is the greatest integer function. It gives you the greatest integer which is less than or equal to the argument of this function. So we need to solve this integral. So let's call the function that is written inside the greatest integer function as f of x, and this is equal to 10x over x plus 1. So let's ask for x which is greater than 0 but less than 10, what is the range of function f of x? So in this limit from 0 to 10, what is the range of this function f of x? This we need to look for. So f of 0 is 0 and f of 10 is square root of 30 over 11, which is close to 3.015. Okay, so it means for x which is 0 greater than 0 or less than 10, the function f of x lies from 0 to 3.015. Okay, nice. So now we know that the argument, this is the value of this greatest integer function can be 0, it can be 1, it can be 2, or it can be 3. So these are the three possible values that this function, let's call this phi of x, can take. Because f of x can go from 0 to 3.015, so that is why the phi of x can take only values 0, 1, 2, 3. Okay, so and we need to solve this integral, right? Phi of x dx. What is this? So now we need to know that when, for what values of x this phi of x is 0, for what value of x the phi of x is 1, for what value of x phi of x is 2, and for what value of x phi of x is 3. This we need to know. Okay, so let's first solve for when f of x is 1. Okay, for what values of x f of x is 1. So it means 10x over x plus 1 is 1. So we solve it. So this is 10x equals to x plus 1. So here is x is 1 over 9. So it means for x equals to 1 over 9, f of x is 1. Or in other way, we can say that for x which is greater than 0 but less than 1 over 9, f of x is greater than 0 but less than 1. Okay, so this is important. Okay, so this means that for x which is greater than 0 less than 1 over 9, phi of x which is greatest integer of f of x will be 0, because f of x is from 0 to 1, that is why the phi of x will be 0. Okay, so now let's see for what x f of x is 2. Okay, so this is 10x over x plus 1, this is 2. It implies 10x is 4x plus 4 and x is nothing but 2 upon 3 when we will solve it. So it means for x which is greater than 1 over 9 but less than 2 over 3, your f of x is greater than 1 but less than 2. So that means then phi of x will be 1 for x greater than 1 over 9 but less than 2 over 3. So this is important. Okay, now we solve for f of x is 3. Okay, so this is 10x over x plus 1 is 3, which implies 10x equals to 9x plus 9, and x will be 9 only. Okay, so it means for x which is greater than 2 over 3 but less than 9, your f of x, okay, is greater than 2 but less than 3. Okay, so that means phi of x will be 2 for x greater than 2 over 3 but less than 9. Okay, now we solve, so it means then for x which is greater than 9 but less than 10, your f of x will be more than 3 but less than 3.015. So that means the phi of x will be 3 in this limit. Okay, so now let's just summarize what we have done. So basically we were trying to look for the values of x for which f of x lies from 0 to 1 and f of x then lies from 1 to 2 here. Okay, then we look for the value of x for which f of x lies from 2 to 3, and then we look for the value of x for which f of x lies from greater than 3. Okay, so the integral that we have was 0 to 10 greatest integer of f of x d of x. So we can just break it from 0 to 1 over 9 greatest integer f of x d of x plus 1 over 9 to 2 upon 3 greatest integer of f of x d of x plus 2 upon 3 to 3 f of x to d of x. Sorry, no, it's not 3, it's 9. Okay, it's 9. Okay, then from 9 to 10 greatest integer of f of x d of x. Okay, sorry. Okay, okay, oh my bad, sorry. Okay, it makes sense. Now what we can do, I'm sorry, it just, okay, cool. So now what we can do is okay, now because from 0 to 1 over 9 f of x is less than 1, so it means this will be 0 dx. Then from 1 over 9 to 2 upon 3 f of x is greater than 1, so this will be 1 dx plus 2 over 3 to 9, this will be 2 dx, and then from 9 to 10 this will be 3 dx. Okay, so now let's just solve it. So this will be 2 over 3 minus 1 over 9. Okay, this will be 9 minus 2 over 3 plus this would be 10 minus 9. Okay, so this we can solve it. This would be 9, this would be 6 minus 1 plus this would be 25 over 3 plus this would be just 3. So this is 5 over 9 plus 50 over 3 plus 3. We can just solve it. This is 5 150 plus 27. This is 182 over 9. Okay, so we solved our integral. So the I is 182 over 9 solved. Okay, so the only piece of information that we need to solve this integral was that how, if you have written something inside the greatest integer function, how does it behave. Okay, so this is like that. Okay, and when we looked for the values of what was the range of this function, and we found that f of x lies from 0 to 3.015, and because f of x was placed under the greatest integer function, then the only pieces of values that the argument of the integral could take was 0, 1, 2 and 3. And then we looked for what values of x f of x is 1, for what values of x f of x is 2, and f of x is 3. Okay, so this is what like we need. we needed. Okay, and and like okay, so okay, and then once we got that, we just break the our integral, like here, break our integral to different ranges, in which the values of this function lies from one integer within one integer to another integer, and then we just insert the values and solve for this integral. I hope you got this question. If you have any comments or suggestions, you can add in the comment section. I will be happy to modify my videos according to that. Thank you.